The ominous box!
I'm going to have a lot of videos starting this way in the near future. Tonight for dinner we're having short block gumbo. Many of the ingredients are either here already or are inside some of the other boxes we're about to go through. I'm going for the more interesting looking box first. I've got a full bloner off camera right now. Sorry folks, some of you know why by this label. I picked up a set of ARP head bolts. They're not L19s, no they're not 625Ss, they're standard ARP 6-bolt 4G63 12mm head studs. Some of you will never be able to overcome that contrast while I would have these rods with those head bolts. The 12mm bolts on the 6-bolt blocks are 1mm larger than most 4G63s. These should be fine for my goals. But these are not your standard aftermarket racing rods. You'll find these rods in a few record-holding 6-bolt DSMs. Upon first glance when opening the box, you're slapped in the face by 2 layers of quality control. The handwritten manufacturer's work order and the weights for both the big end and the pin bores written on each individually packaged box. In one of the processes of balancing a rotating assembly, you'd want to get the rod's weight within a gram of each other. They've done this already on both ends. It saves a lot of time. These Manly Turbo Tough I-beams are forged from 4340 aircraft quality vacuum degassed low alloy steel. Heat treated and oil quenched, shot peened and 100% Magnaflux to ensure their integrity. But there's something a little different about mine. The part number for a standard 6-bolt rod is 14413-4. These are 14407-4s. These 6-bolt rods have a 22 instead of a 21mm pin bore. Manly I-beams come with ARP 2000 cap bolts, but you can upgrade those fasteners to ARP 625 pluses for an enormous fee. Be aware that 625 alloy fasteners require special handling precautions. But what I was saying about the pin bore, there's no real advantage to the bigger pin. Sure, maybe a 22mm pin is technically a little stronger. Sure, it may have a larger oiled bearing surface connecting the piston to the rod to transfer all those forces. But they're heavier. That's actually a disadvantage if anything, because there's nothing inadequate about a 21mm pin to begin with. If you were using a 6-bolt and you haven't ordered your pistons yet, then you would probably need the standard rods and pistons for a 6-bolt. I'll be using a 7-bolt piston on my build. I wanted to point that out in case anyone buys these rods using the same part numbers as I did. Also in the box are about 20 horsepower's worth of stickers to tune with, the material safety data sheets. You can tell these are completely stable and non-toxic, pose no health hazards, and aren't very reactive. The number 1 on top simply means they have a flash point above 200 degrees. They were forged at over 2200 degrees. We're in no real danger here. The one you don't want to lose track of is this install sheet. It's part of your blueprint. Even though it's printed, it's not blue. It has valuable information like clearances for the rods and block, oil clearances for the big and small ends, rod gap clearances, and all the torque specs for the fastener options available on Manly products. These 6-bolt 4G63 rods use the same 3/8 inch by 1.6 inch ARP 2000 fasteners found on most small block Chevys. Just so you know. Let's take a look at the work order one more time. These things are just meaty and massive. Each rod is within a gram of these specs. Yes, it's true, I've been sitting on this video for 2 months. Sorry, it hasn't been easy, trust me. I've been wanting to leak this video out for a while now. Also in one of the boxes you'll find a tube of Manly assembly lube for the rod bolts. It's part number 40171, which really just means it's a 1-ounce tube. There's a 2-ounce tube available as part number 40172. Imagine that. I bet you $1 it's the exact same repackaged ARP Ultra Torque lube. They're ARP bolts after all. Why would Manly need to be manufacturing lubricants? I guess I'll find out. The torque specs on the data sheet will reflect the supplied or recommended lubricant, whatever it might be. You've probably never seen a brother change his digs that quick with or without the phone booth. I've got some more stuff to open, but how can I top the last box, right? Look, I don't know what order to open this stuff in. Hang around because there's plenty more. This box contains mostly necessities, but what is this here on the bottom? Oh, nothing much really. Just a Kigley Racing main bearing girdle. This is one precision cut piece of work. The purpose of this part is to be the cream filling between the mains and the fasteners, rigidly locking the main caps in place. The 7-bolts have this from the factory, but this part is a solid and inexpensive way to add that strengthening feature into a 6-bolt engine block. Some grinding of the block will be required for fit, and you should closely follow their installation instructions. These are all the OEM Mitsubishi gaskets for a 6-bolt short block. I always use OEM for these kinds of parts. There really is no better way to do it right. I have nothing bad to say about ACL H-Series tri-metal bearings. If I did, I wouldn't have had them shipped to me. For the love of God, don't ever use Alumaglides on a Turbo 4G63. This is the part number you'll want to use for a 6-bolt if your crank and main journals have never been turned or bored out of spec. There are oversized and undersized bearings available, and they have different part numbers. There's 2 packs of bearings shrink wrapped in different colors on the inside. This indicates the bearings are different. There's a set of bearings with an oil groove cut parallel to their faces, and another set that are smooth. The ones without the groove go inside the main caps to increase the bearing surface area under load, and the ones with the groove go against the block to aid the oil delivery to the bearing faces. For the rods, once again, I've got standard 6-bolt ACL H-series rod bearings. They all come shrink wrapped together. There's no need for a grooved bearing here. This is the last stop before the oil leaks back into the oil pan. Just be sure to align all of your oil holes during assembly. What happened to my workbench? And how did it get so filthy all of a sudden? Not having that. Before I dig any deeper, I need to clean house. I want to go over the rest of my parts, and it's really important that I don't get colt funk and grit all over them. Bear with me a moment. More parts arrived while I was buttoning up the Colt. Stuff that I'll need in order to complete both the short block and the cylinder head. Oh look! Performance peanuts! I wish I had a wife so somebody could be pissed off at me for buying this stuff. This is a set of Kelford 272 camshafts, both intake and exhaust. These make a little bit more lift than most, and their aggressive profiles require top-shelf valve springs to keep valve lash under control. So along with these comes a set of high-pressure Kigley Racing Beehive valve springs. Also in the box we find a 6-bolt oil strainer. I'm not a fan of cleaning and reusing oil strainers. I just replace them with a new one to avoid questioning whether or not I got all the junk out of it. We have another bag full of fasteners, seals, balance shaft elimination parts, and other goodies. We'll get back to these bags in a minute. Also, while finishing up the Colt, I spent some time with my machinist getting some parts worked and refurbished. One of them being my old set of 2G JE 20 overbore 9-to-1 compression pistons that were in the 7-bolt. I was ecstatic to find nothing wrong with these after the failure I experienced with it. They were expensive. Not only that, they've been fantastic pistons in my application. I've got about 45,000 miles on them so far. We removed the old 7-bolt rods and cleaned them up to be mounted on my new 6-bolt rods. They came out great with very little work. No modification is necessary to these pistons to make them fit the rods I selected. They have full floating wrist pins, so nothing has to be pressed together like you'd need to do with a factory piston. Just slide out the pin, stick the rod in there, and push it back through. The pin is held in place by snap rings on either side. When you're cleaning these up, you want to get all the gunk and carbon out from between the ring grooves and the oil holes, and to be careful not to scratch them up. I was thrilled to find a complete lack of buildup in the grooves, and I blame my engine oil selection and maintenance schedule for depriving me of that work. Here's the other 4 snap rings for the pins. They were nice enough to make sure I had them. I'm putting all this back until I need it, but let's deviate from the short block parts for a minute and check out the head candy. These are Kigley beehives. They call them beehives because they become narrower near the top, making them look like a beehive. The purpose of this is to provide a progressive spring rate while increasing the distance they can be compressed without binding. Also, the narrowing top end focuses the lifting force closer to the valve stem, reducing deflection of the springs. Each one is topped off with tit retainers. I can't stop calling them that. Everyone abbreviates titanium, so to me they'll forever be known as tit retainers. The lower seats are included, and I need to take all this stuff up to the machine shop for measurement and fitting because I can't afford the tools that do this. These Kelford cams have about 4/100ths more lift than an Evo's cams do. 11mm lift versus 10mm, or 433 thousandths of an inch. The detailed spec sheet is included and it has suggestions for where to degree the cams. Both lift and duration are means of increasing airflow through the cylinder head ports. Let's take a look. Oh, nope. Sorry guys, this is a short block parts video. I have to save something for later. We need to get back to the short block parts. This is the only part that isn't for the short block. These are oil gallery plugs for the cylinder head. I stole them from my spare head a long time ago and I'm putting it back to use now, so I needed to replace them. First up for the short block we have the oil pump oil seal that fits behind the oil pump sprocket. Simple enough. Next we have the rear main seal for the crankshaft. Don't even ever think of reusing these parts. Replace these whenever you're in there. Since there's 2 ends to the crankshaft, we have the crank seal for the front case. Pretty important stuff. Next we have the gasket for the rear main seal carrier that bolts to the block behind the flywheel. On the other side of the block there's also this huge front case gasket. It's not the only thing that bolts between the front case and the block, but we'll get there. There's also the oil strainer gasket. Don't use Permatex or RTV for this part. Leave nothing to chance where it comes to your oil system. I've got an oil filter housing gasket that goes between the front case and the oil filter housing. This is the turbo oil drain tube gasket, and two of them are employed to do their jobs, one on each end. Not reusable, because not only myself but my friends frequently need to break this seal due to problems they experience. My spares dwindle and I like to have at least one extra of these. This is a bolt kit for the 6-bolt oil strainer. It contains 2 bolts with captive lock washers, a nut, and a loose lock washer. For $2 I don't have to clean red Loctite off my old oil drain bolts. Not bad. Next we have a stub shaft from a 1.6 liter 1989 Mirage. This part takes the place of the rear balance shaft to support the oil pump gear and solves the internal oil leaks that can result from cutting the balance shaft off and not properly sealing the oil hole through the center of the shaft. Everyone has a different way of dealing with it, but I just use factory parts and call it a day. Because my balance shafts are being removed, there's a useless and unused balancer belt sprocket behind the timing gear. This spacer replaces that sprocket and slightly reduces rotating mass of the crankshaft. Not a bad plan. I've never used it before, but we'll see how this goes. I will be installing oil squirters back into my 6-bolt block, and they had to be removed during machining, so now I need new crush washers for all of them. I also picked up a new set of balance shaft bearings, even though there's no balance shaft. This needs to be installed 180 degrees out of phase so that the oil hole in the block is sealed. This is the front balance shaft bearing and it needs the same treatment. On the front shaft there's usually a balancer belt sprocket protruding through the front case. This is the rubber seal that blocks off that hole once the balance shaft is removed. I picked up a new set of dowel pins for the cylinder head where it bolts to the block. These keep the head centered when you're bolting everything down. There's also a set of dowel pins that go between the front case and the front of the block. Don't leave these out of your build because they line up all the oil galleries between these parts so that oil flows correctly where it needs to go. There's also 2 dowels that live between the rear main seal carrier and the block. Last dowel pin in the mix is for the crankshaft. This piece is sandwiched between the tail end of the crank and the flywheel. Finally, an extra oil strainer gasket. The gasket's so nice that I bought it twice. I didn't need 2 of them, I just forgot that I bought it the first time, and so now I have 2 of them. Well, there you have it. That's everything you need to assemble a short block. Of course, everyone does things a little bit differently, but this is a good baseline if you're rebuilding a 6-bolt 4G63. The rods, cams, springs, balance shaft hardware, and the pistons may vary depending on the builder's goals, but these gasket seals and this group of hardware is what you need at a minimum if you had all the other parts. Subscribe if you want to follow this build. There's a comment section if you have experience or suggestions to share. Until next time, stay tubed.